Yes. Hello everyone, this is D. Chinnagokari and I am going to explain about the spectrum which is belongs to the atomic structure chapter, one of the important concept. So this is only the major concept to understand the hydrogen spectrum. Okay, first of all, what is spectrum? Spectrum we already know, that is group of wavelengths is called spectrum. So when you pass a white light through a prism, it gives different colors like violet, indigo, blue, green, yellow, orange, red color, like that different colors it gives. It is one of the spectrum, and the instrument is used to record the spectrum is called spectrometer or spectrograph. It is called spectrometer, and here the image what we record by using this spectrometer, it is called spectrum. Okay, so the image which we recorded by using a spectrometer, that is called what? Spectrum, or simply we can tell it as a group of wavelengths is called spectrum. So now let us discuss type of spectrum. Type of spectrums. Type of spectrum. So here mainly we are having two type of spectrums, that is continuous spectrum, continuous spectrum, and discontinuous spectrum. So here what is a continuous spectrum? Continuous spectrum is nothing but here one color is merges on another color, merging of one color on another color, light, violet, indigo, blue, green, yellow, orange, red. So here one color is merging on over another color, like in the rainbow, one color is merges on another color, that is called continuous spectrum. Then what is discontinuous spectrum? In discontinuous spectrum, one of the color is missing in a spectrum. Say for example, let us take one spectrum here. Spectrum is nothing but we already know it is an image. So when you take the image of this light, so here we have violet, indigo. So here blue color is missing, some gap is there, and then after green, yellow. So here orange is missing, then after red color is there, which means is there any gap? If is there any gap in between the wavelengths or in between any colors, that is called what? Discontinuous spectrum. For continuous spectrum, we can tell one example, that is passing of white light through a prism. So there we can observe merging of one color with another color, like rainbow. So when you see the rainbow, so there we can see 7 colors, one color is merged with another color, that is a continuous spectrum. And what is the example for the discontinuous spectrum? So when you record a spectrum of any color object, so when you record the spectrum of any color object, so here for example let us take one red glass. So when you record a spectrum of a red glass, we can see only red color, but remaining colors are missing. So that is discontinuous spectrum. Okay. Again, this spectrum is again classified into two types. That is, this is main classification, that is absorption spectrum, absorption spectrum, and emission spectrum, absorption spectrum and emission spectrum. absorption spectrum and emission spectrum. So what is absorption spectrum? So your absorption spectrum is nothing but when you pass a light through a sample, when you pass a light through a sample, so here this sample is going to, when you pass a white light, when you pass a white light through a substance, so this substance is going to absorb the some of the radiation, absorb the some colors in this white light, and it is going to transmit some colors from the this solution. So when you pass this through a spectrum and when you record this spectrum, this is called what? This is called, here we will get a bright background, here we get a bright background and small gaps, some small gaps. Here we are going to get, some bright lines and some small gaps in the different color regions. So that is nothing but here it is absorption spectrum. So here it is absorption spectrum. What we are going to study? We are going to study the properties of transmitted light. We are going to study the properties of what? Transmitted light. So when you pass a white light through a sample, what the sample is doing? The sample is absorbing some part of this light and it is transmitting remaining part of the light. And when you pass this remaining part of this light through a prism, so obviously, so here the colors which is absorbed by this solution is missing. So that is nothing but here absorption spectrum. For example, when you pass a white light through sodium, Na, sodium metal, so here when you record the spectrum of the sodium metal, we can observe some dark lines. Over a bright background at 5890 and 5896 Armstrongs. At this range we can observe the two dark lines over the bright background, which means in this white light, what this sodium is doing, this sodium is absorbing these two wavelengths and remaining wavelengths it is transmitting. So this type of spectrum is called what? Absorption spectrum. So this range falls in the yellow region of EMR, electromagnetic radiation. And coming to the emission spectrum, so here emission spectrum is nothing but here we are, when you pass a white light, when you are going to pass a white light, or when you are going to pass any light or radiation through a gas substances, so what these substances are doing here, these are going to absorb the some radiation. We already know remaining radiation they are going to transmit, but after some time what we are going to do, we are going to stop the heating of this substance. Then that time what happens, initially when you are supplying heat energy or when you are passing some discharge, so the electrons which are present in the substance, they are going to absorb radiation and they are going to enter in the higher energy levels. And then after what they are going to, here higher energy state is less stable. That's why again they return to the ground state. When they return to the ground state, they emit the radiation, and we are going to send this emitted light through a prism, and we are getting a spectrum or image of the light. So that is called what? Emission spectrum. So in this emission spectrum, when you heat the substance, what is happening? The electrons or the molecules are absorbing the energy, and the electrons are entering into the higher energy level. that higher energy level is somewhat very less stable, so that again they return to the ground state. When they are returning to the ground state, they are releasing some radiation. That radiation we are going to pass through a prism, and here we are getting a spectrum. This spectrum is called what? Emission spectrum. So in emission spectrum, we are going to study properties of emitted light. Properties of emitted light. So here, when you pass a electric discharge through sodium, when you pass the electric discharge through sodium, so here this sodium is going to release some yellow color. So in the range of 5890 and 5896 Armstrongs. So here, which means here we are getting bright lines over a black background. So bright lines over a black background. So this is all black background, and here these two are what? Bright lines. These are the two bright lines, and on a black background at which region? 5896, 58 at we are getting. So when you pass a light through a sodium, we are getting a spectrum like this. We are getting a spectrum like this, bright lines over a black background. So here we can consider this whiteboard as a black background, and this blue line has a bright lines, but they are at which region? 5896 and 5890 Armstrongs. At this region we are going to get the bright lines. So this is about absorption spectrum and emission spectrum. So what are the differences between the absorption spectrum and emission spectrum? So in absorption spectrum, we are going to study the properties of transmitted light. In emission spectrum, what we are going to study? Properties of emitted light. Okay. So now let us differentiate them, emission spectrum and absorption spectrum. What are the differences between emission and absorption? Emission and absorption spectrum. So here, what is a absorption spectrum? So absorption spectrum is due to what? Absorption spectrum is due to excitation. So excitation of electrons are entering into the higher energy levels, and are absorbing the high energy. And what is emission spectrum? Emission spectrum is due to de-excitation of electrons, means when they are present in the higher energy level and they are coming to the ground state. Next, in absorption spectrum, we are going to study about the properties of transmitted light. We are going to study the properties of transmitted light, whereas in emission spectrum we study the properties of emitted light. Properties of emitted light. Next, in absorption spectrum, we are, how the spectrum is? Spectrum is black or how the spectrum is here? Dark lines on bright background, and whereas emission spectrum is bright lines over black background. So absorption spectrum is like negative of the emission spectrum, and emission spectrum is a photo of absorption spectrum. So these are the some differences between emission spectrum and absorption spectrum. And again here absorption spectrum and emission spectrum again classified into continuous spectrum and discontinuous spectrum. Okay. So again these absorption and emission spectrums are again classified into two types. They are absorption continuous and absorption discontinuous. Absorption discontinuous. And again discontinuous spectrum again classified into band spectrum and again it is classified into band spectrum and line spectrum. So here emission spectrum is also again it is classified into continuous emission spectrum and discontinuous emission spectrum. Again this discontinuous emission spectrum again classified into band spectrum and line spectrum. So here what is absorption continuous spectrum means? So here we can take a black body. So here continuous absorption spectrum means this is due to absorbing the continuously different wavelengths. For example, when you take a red glass radiation, when you take a red glass radiation or violet glass radiation, when you take a red glass radiation, so a red glass when you pass a white light over the red glass, so it emits only or it transmits only red color. Remaining colors it absorbs. Remaining colors it absorbs. So when you draw a spectrum or when you take a spectrum of this red glass, will get only red color over the spectrum, and the remaining all is what? Remaining all is like this continuous only. Okay, this is what continuous spectrum. So the red color glass is the example for continuous absorption spectrum. Next, discontinuous absorption spectrum. First of all, discontinuous band spectrum. So when you pass a light through KMNO4, it gives 5 bands in the green color region. It gives 5 bands in the green color region, which means you have 5 colors over the this green color range. Like this 5 bands it produces in the green color range. Okay, which means what it is doing, KMN4, it is absorbing the remaining all colors, it is transmitting only green color. Okay, so that is band spectrum. And absorption light spectrum is the example of sun radiation. sun radiation. When you see the sun radiation, so here we will get different lines, like not like bands, but lines, like we get different lines, different dark lines will get in the sunlight, sun radiation. Okay, different dark lines here we get. So this is nothing but a line absorption spectrum. By using this line absorption spectrum only, they discovered the different elements in the nucleus, in the surface of sun, like helium, hydrogen. They discovered the by using this light absorption light spectrum. Next, emission continuous spectrum. So what is a emission continuous spectrum? If any object emit all type of electromagnetic radiations continuously, that is called emission continuous spectrum. For example, for emission continuous spectrum, hot iron. So when you heat the iron, we already gives initially dull red color, then after green color, then after blue color, like that continuously it gives when you heat that iron object. So that continuously it gives the different colors without any gap. And coming to the discontinuous emission spectrum, again this discontinuous emission spectrum again classified into two types: emission band spectrum and emission line spectrum. So here band spectrum, what is nothing but we will get bands. We will get what? Bands. And in emission line spectrum we will get lines like this. In emission band spectrum we will get bands. Okay. So this is the emission line spectrum and emission band spectrum. So emission band spectrum is an example: heating of metallic salts with charcoal core. So they will give the bands, different bands in the different regions. Different bands in the different regions. And what is the example for emission line spectrum? Emission line spectrum, for example, heating of vapors of gases like sodium vapor, mercury vapor. So when you heat that type of vapors, what they are going to do? They will give some lines in the spectrum. That is called emission line spectrum. So for example, when you heat the sodium vapors, when you heat the sodium vapors, the sodium vapor give two bands in the 5890, 5896. So this emission line spectrum is also called atomic spectrum. Emission line spectrum is also called atomic spectrum. Why? Because by using this emission line spectrum, we can discover it is the characteristic of atoms. That's it. It's the characteristics of the atoms of particular atom, like our fingerprint. So a fingerprint can detect the person. Here also, by line spectrum can also detect the elements. That's why it is also called atomic spectrum. And band spectrum is called molecular spectrum. By using this band spectrum, we can detect the molecules. Okay. So this is about emission spectrum and absorption spectrum. And now let us discuss about hydrogen spectrum. So here when you pass a light discharge or electric discharge through hydrogen gas by taking a discharge rate, when you pass electric discharge into the hydrogen gas, so here hydrogen gas is going to emit some radiation. So this radiation is passed through a prism, and here we are going to get a spectrum. So this is called what? Hydrogen emission spectrum. So here hydrogen emission spectrum is nothing but when you pass a electric discharge through the hydrogen gas. So this hydrogen gas is going to release some radiation, and we are going to pass that radiation through a prism, and Here we are getting a spectrum, that is nothing but here hydrogen emission spectrum. So when you see the hydrogen spectrum, you can observe different lines like this, different lines. So these different lines are named as with different names, with different scientists, with the names of the discoverer of the scientist. So here first line is known as Lyman series, and it is known as Balmer series. It is known as Passion series, it is known as Bracket, it is known as Fund series, and this is known as Humphrey series. So this is the spectrum we observe. This is the spectrum we observe in the hydrogen spectrum. These are the lines, these are the different lines we observe in the hydrogen spectrum. Here each line is discovered by different lines, like Lyman series is discovered by the scientist Lyman, Balmer series is discovered by the Balmer, Passion series is discovered by the Passion, Bracket and Fund, like Humphrey. So there are the different lines are there in the hydrogen spectrum. And here first line, it is we observe the Lyman series in the UV range, ultraviolet range, it is in the visible, and these 3 are and 4 are IR, means one is near IR, middle IR, and this one is the far IR. So which means in all these series we can see only Balmer series with our naked eye. So for Lyman series, so let us, it is a name n equal to 1, here n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6. And here scientist Rydberg calculated the wavelength and frequency by using a equation, that is nu bar is equal to, means wave number or wavelength 1 by lambda, that is equal to RH into 1 by n1 square minus 1 by n2 square. By using this equation, we calculate the wavelength or wave number of particular frequencies. Means when the light is, when the electron is coming from this region to, means Balmer series to Lyman series, it emits some radiation, and for this radiation he calculated the wave number of lambda by using equation RH is equal to 1 by n1 square minus 1 by n2 square. So here what is RH here? RH is called Rydberg constant. So scientist Rydberg calculated the frequency. So it is the RH is the Rydberg constant. Its value is 109,677 centimeter inverse. So this is the Rydberg constant. Here what is N1? N1 is the lower energy level. N2 is the higher energy level. So here when you go from lower energy level to higher energy level, the distance between the lines decreases. The distance between the lines is decreases, and the energy gap is also decreases. The distance here, it is having much distance, it is having somewhat less distance. Likewise when you go to the higher energy levels, the still distance is decreasing. Finally the lines are merging with one another. So finally we get a lines like this. This is called what? Limiting line. So indicated with alpha. So this is about different lines in the hydrogen spectrum. In the next video I will explain how the Bohr explained this hydrogen emission spectrum and what is the Bohr's atomic model and its postulates. Okay, yes, this is about spectrum and everything up to hydrogen spectrum. Okay, so if you like the video, give a thumbs up and press the like button, and if you have any doubts regarding the class, you can comment. Okay, I will try to give explanation. Thank you.